All right, now I want to talk about motion graphs. It's very, very important that you understand how to interpret these motion graphs. In this class, we're going to actually talk about 3 different kinds of motion graphs. The first 2, one is called a position versus time graph. And when we say position versus time, you might also see distance versus time. You could also see displacement. M-E-N-T, displacement versus time. All those 3 are the same type of graph, so you might see any of them, and you need to know that they're all the same thing. The next type of graph we'll talk about is called a velocity versus time graph. Plots velocity against time. And the third one is actually acceleration versus time. The second 2 we won't talk about for a little while to come. Right now I want to focus on position versus time. So here we have a position versus time graph. Position is graphed on the y-axis, time in seconds along the x-axis. The first thing I want you to know about a position versus time graph, it's very important that you know that slope of a position versus time graph represents speed or velocity of the object depicted in the graph. And I'll prove that to you, that slope represents speed. If we calculate the slope, for instance, the slope from 0 to 10, we calculate slope by calculating rise over run, which in terms of variables is the y variable over the x variable, change in y divided by change in x. In our case, our y variable is position, and the units for position are meters. The x variable is time, and the units for time are seconds. So if we calculate a slope and we do y over x and we divide this out, our units for that will actually be this, and you might notice that this is meters per second, which is it's the most common in physics unit for speed and velocity. That's how we know that the slope of this position versus time graph must represent velocity. So anytime that you see the word slope with a position versus time graph, you can substitute the word speed in there. Because everything you can tell me about the slope of this graph is also true about velocity. There's actually 3 things that we can tell about the slope of the graph. So we're going to add another one in here. The first thing that we can tell, that the slope can tell us, is what the actual speed is. In other words, the number. I can actually calculate this slope and I can come up with the speed. The second thing that the slope can tell me is the direction of motion. Whether that's positive or negative. And I simply look to determine that. I can look at the slope of the line and decide whether the slope is positive or negative. The third thing that I can tell about the slope is whether it is constant or changing speed. All right, so just more in detail, as far as actual speed, again, all I have to do is calculate the slope. So if you get a question, and sometimes you will be given a graph that looks just like this. And it will say, for instance, what is the speed of this object between 0 and 10 seconds? And remember, when you hear the word speed, remember these 2 words, they need to be interlocked in your mind. When you hear the word speed, you can think slope. When you hear the word slope, you can think speed. And if it says, what's the speed between 0 and 10 seconds, you should be thinking, what's the slope between 0 and 10 seconds? Because if you find the slope, you find the speed. And all I have to do to find the slope between 0 and 10 is rise over run. Rise is 2 meters. Run is 10 seconds. So 2 meters divided by 10 seconds gives us 0.2 meters per second. It's that simple. If I find the slope, that gives me the actual speed of the object. Second thing I can know is the direction of motion. You should know that this is a positively sloping line. This is a negatively sloping line. Okay, everything going this direction is positive. Everything going this direction is negative. Negative slope. So it's a positive slope, that means that object is moving in a positive direction. It has positive velocity. Positive and negative only indicate direction here. So if the slope is positive, it's moving in a positive direction, meaning going forward or going to the right or moving up. If it's a negative slope, it's moving in a negative direction, moving backward, moving to the left, moving down. So I could ask the question, where on this graph is the object moving backward? And you would tell me from 20 to 35 seconds, because this is the only place on the graph that has a negative slope. Where is the object moving forward? Only place it's moving forward is from 0 to 10 seconds. That's the only place there's a positive slope. Positive slope, positive velocity. Another question, what's happening from 10 to 20 seconds? Once again, if we think in terms of the slope, from 10 to 20 seconds, the slope is 0. And where we see the word slope, we can substitute the word speed. Slope is 0, speed is 0. This object is standing still, the same as right here. So this object moves, let's keep going to number 3. The third thing that this can tell us is whether the speed is constant or changing. Constant speed is depicted by a straight line. Straight line. Again, if the speed is constant, the slope will be constant. Constant slope means straight line. Straight line, constant slope, constant speed. And in this graph, all of these portions are actually constant speed. They're all straight lines. The speed changes instantaneously at these points from positive to 0, from 0 to negative, and then from a negative speed back to 0. But other than that, at all these points where we have a straight line, there's constant speed. Constant speed of 0.2, constant speed of 0. This happens to be a constant speed of negative 0.2. If you calculate that slope, which is the speed, that's a negative 0.2 meters per second. Constant speed of 0. So we can calculate the actual slope, that'll tell you the speed. You can figure out the direction of motion as to whether the slope is positive or negative. And you can figure out if it's constant speed or non-constant speed. And for instance, we might have a graph that looks like this. This is not constant speed. This could be position versus time as well. This speed is not constant because the slope is not constant. The slope is ever changing. If we look at the slope here, it might look like this. If we look at the slope here, it might look like this. Those two slopes are not the same. The slope is increasing. If the slope is increasing, the speed is also increasing, because on a position versus time graph, slope represents speed. How can we tell if an object is moving? In this graph, we can tell if it's moving if the position is changing. How can we tell if an object is going forward or backward? Whether the slope is positive or negative. Positive for forward, negative for backwards. Look at these 6 graphs. They're all position versus time graphs. I want you to pause the video for just a second and try to decide in each graph which direction the object is moving and whether it has constant or non-constant speed, and if it's non-constant, what that speed is doing. Is it speeding up or slowing down? All right, you had a minute to think, hopefully. In this one, which direction is the object moving? This would be positive velocity because we have a positive slope. So it's moving forward or in some positive direction. What about the speed? Is it constant or not? Well, we have a straight line, so when we say speed is constant. Speed is constant. Straight line, speed is constant. This one, we have a straight line as well. Speed is constant, not changing. But what direction is the object moving? Slope is negative, speed is negative. This object is moving in a negative direction. This graph here, which direction is the object moving? We have a positive slope the whole way, so this object is moving forward. Speed is positive, moving forward. What is happening to the speed? Well, the speed is changing because the slope is changing. If we have a curved line, our slope is ever changing. And in this case, if we look at each one of these lines, the slope is getting steeper and steeper and steeper. We're increasing our slope. So if slope increases, that means speed increases. If our slope is increasing, our speed is increasing. What about this one? What direction is the object moving? All these slopes are positive. Positive slopes. It's moving in a positive direction. What's happening to the speed? These slopes are getting ever shallower and shallower. So if the slope is decreasing, the speed is also decreasing. Non-constant speed, the speed is decreasing. Speed is increasing, speed is decreasing. What about this one? What direction is it moving? All these slopes are negative. They're sloping down in this direction. So we have a negative velocity. Object is moving backwards or in a negative direction. And these slopes are getting from shallow to steeper to steeper to steeper. The steeper the slope, so this slope itself is actually increasing. Even though it's a negative slope, the slope is increasing. The number or the measurement of the slope is increasing. Therefore, the actual speed is increasing. That may be a little bit tougher to see. You can understand this positive slope increasing, it's getting steeper. The slope is moving a different direction, but it's still increasing because it's getting steeper. So, object moving in a negative direction, the slope is increasing, therefore the speed is increasing. What about this one? Here's our slopes. Slopes are all negative in this case. They're all negative slopes. Therefore, we're going to have a negative velocity. This object is moving backwards or in some negative direction. And this slope starts out very steep and gets shallower and shallower and shallower as we go along. So therefore, the slope is getting shallower. That means it's decreasing. And if the slope is decreasing, the speed is also decreasing.